Hello everyone, welcome to Data Structures class. In this video, we will talk about priority queue and how to implement stack and queue. In a regular queue, we treat all objects equally by adding an object into the queue from the tail and processing the object at the head of the queue. This indicates that a regular queue processes objects on the first come, first served basis. In some real-world scenario, we would like to handle urgent cases first. For example, emergency nurses in the ER need to perform triage of patients according to the type and severity of their presenting signs and symptoms. As you can see, on the basis of a Canadian triage acuity scale, a patient classified as level 1 resuscitations need to be cured immediately, while a patient classified as level 5 non-urgency can be cured within 120 minutes. This indicates that we need to design a queue to handle objects with different priority, where objects with high priority will be served before objects with lower priority. For objects with the same priority, they will be handled on the first come, first served basis. Here, we demonstrate an example of priority queue. In this example, we assume that there are 3 priority levels, including high, as shown in red, normal, as shown in green, and low, as shown in gray. We have a set of tasks representing as A to F with different priority levels. For instance, task A is a normal priority. Task B is low priority, and task F is high priority. Tasks A to F are submitted to the queue in alphabetic order. As you can see, we submit task A with normal priority to the queue first, and A is the head of the queue. Second, task B with low priority is added to the queue. According to the first come, first served basis and task priority, task B will be served behind task A. Third, task C with normal priority is submitted to the queue. According to the task priority and first come, first served basis, task C will surpass task B and stay behind task A. Similarly, task D with low priority will be added to the queue after task B. Task E with normal priority will pass the 2 lower priority tasks B and D and stay behind task C. As there is no high priority task in the queue, task F with high priority will pass all low priority and normal priority tasks to reach the head of the queue. To implement a stack, As you can recall, a stack is a list of objects which are pushed into the stack from the top. We can use the following two approaches to design such a mechanism. The first approach is array-based approach, and the second approach is linked list-based approach. We can create an array to simulate a stack by creating a variable top to hold a subscript, which points to an element representing the top of the stack. When the stack is empty, we set the variable top as null. When an object is pushed into the stack, we increase the top variable by 1 and assign the object to the element pointed by the top variable. When an object is pushed into the stack, we increase the top variable by 1 and assign the object to the element pointed by the top variable again. When an object is popped out of the stack, we retrieve the element pointed by the top variable and then decrease top variable by 1. When we perform pick operation, we retrieve the element pointed by the top variable without changing the top variable. In this way, we can simulate a stack operation using an array. We can also use linked list to simulate a stack. To simulate a stack using a linked list, we can create 3 methods in the linked list. First, we create a method push that adds a new node as head node at the beginning of the linked list. Second, we create a method pop that retrieves the data from the head of the list and then removes the head node. Third, we create a method pick that retrieves the data from the head of the list without removing the head node. For example, if we want to push 7 into a stack, we create a node to store 7 and add the node to the head of the list. If we want to push 11 into the stack, we create a node to store 11 and add the node to the head of the list. If we want to push 3 into the stack, we create a node to hold 3 and add the node to the head of the list. If we want to push 26 into the stack, we create a node to store 26 and add the node to the head of the list. If we want to pop the top of the stack, we retrieve the head node to obtain 26 and remove the head node from the list. If we pick the stack, we retrieve the head node to obtain 3 without removing the head node from the list. The similar approach can be used to implement a queue. However, to implement a queue using linked list, when adding a new object into the queue, we insert a new node at the tail of the linked list. When removing an object from the queue, we retrieve the value from the head node and remove the head node from the linked list. When picking the queue, we retrieve the value from the head node without removing the head node. It is not appropriate to use an array to implement a queue because array is not flexible for element insertion or deletion. Any questions?